Oh, hey, hey, buddy. We have not had any success yet, but
Saw someone was in the chat.
yeah, got a lurker.
Oh, yeah,
Don't mind me, it's fine.
it's a TikTok thing.
Really.
It's on the tops. Have you been opening your window at all?
The window. It's open during the day.
He looks
Oh, I didn't turn the mic off again. Oops. Alright, back. I forgot to set the timer again, I guess. I wish I had, I wish it was just fully automated, you know? That would be ideal. I don't know how to do that, though. Anyways, we're gonna do some, we're gonna get started in Rust, which is what I've been waiting for, because Rust is awesome, and, I'm stoked to learn more and get better at it. You know, just be able to contribute to society in general, both physical and virtual. So let's go back. Where are we? We're here. Let's go. So dashboard workspace 2 can be still our general space. Workspace 4 is for after the stream. Workspace 6 can be us setting up Rust. So we're going to need that. We're going to need this. It's the classic layout of web page, terminal. Nice. It's like the first time I got on the first try. So we should have Rust installed. Let's just go to the Rust code and make sure, well, Rust install. Just make sure everything's installed properly before we start running into other errors. I think it is though, because I had to install it to get Neovide working. And I really want to get, if I could get enough to where it wasn't like a huge deal for me to fix some stuff in Neovide, because I want to be using Neovide because it's sweet. So this is the curl stuff. Like auto detect my OS, download Rust up, install, and the following commands. Yeah, so I've already run this. Sage. This runs like a shell command. Okay. So after installing, running, should be able to run Rust version. Yeah, we're at 1.53. And then with the Rust book, do the Rust thing, of course. Okay, well, I guess that's all installed properly. So, part of what we're gonna have to do, like this is step 1, which we were just working on, and I'm gonna run it for the stream. Step 2, I'm probably gonna have to look at setting up a Flex dashboard in R, but my coworker is working on that independently, so it's probably better that I hold off for a little while. Do that later. Once we have a copy in place, I can look at this. But something I can work on now is getting data into the dashboard. So we're going to need to be able to pull some data online. So we're going to have a web scraper build an API. So when I was looking at web scraping, I was seeing a lot of most stuff that I was looking at in Rust was involving Tokio, which from my understanding is like an async library. It's like a crate that lets you do async. And it's like web scraping, so you need the async for the crawlers, I guess. But I was even seeing it on stuff for embedded Rust, which is like, pretty insane span. Like that span is one of the things that drew me to Rust to begin with. So we're gonna start with some Tokio. Not that Tokio. I don't know if it's pronounced Tokai or Tokyo. Let's actually go to the site too. Tokyo. Rust. Let's go here. .rs. Tokyo.rs. Okay. I went to the wrong thing. Oops. Let's actually just move this to 6. And then start a new one. I'm getting the hang of this. Go this. Getting the hang of it. All right. Build reliable network applications without compromising speed. Never want to compromise speed for anything. Tokio is an asynchronous runtime for the Rust programming language. It provides the building blocks needed for writing network application. It gives the flexibility to target a wide range of systems from large servers to dozens of small cores. Large servers with dozens of small cores to small embedded devices. Where's it getting started? Okay, so bring it to tutorial. This is where I was about to go, so that's good. Built by the community for the community. It's like AWS, Microsoft, Facebook. Don't know what these other things are. I mean, I know Comcast and Dropbox are, but some pretty big companies. Reliable. Tokio's APIs are memory safe, thread safe, and misuse resistant. Misuse resistant. I like that. This helps prevent common bugs such as unbounded queues, buffer overflows, and task starvation. Fast. Building on top of Rust, Tokio provides multi-threaded work-stealing scheduler. Applications can process hundreds of thousands of requests per second with minimal overhead. Flexible. The needs of a server application differ from that of an embedded device. Although Tokio comes with defaults that work well out of the box, it also provides the knobs needed to fine-tune to different cases. Async await. Reduces the complexity of writing asynchronous applications. Paired with Tokio's utilities and vibrant ecosystem, writing applications is a breeze. The stack. Applications aren't built in a vacuum. Tokio Stack includes everything needed to ship to production fast. Okay, so I can just scroll through this. This is sweet. Runtime. Including I/O, timer, file system synchronization, and scheduling facility, the Tokio runtime is foundation of asynchronous applications. Hyper. The HTTP client and server libraries support both HTTP 1 and 2 protocols. Tonic. The boilerplate free gRPC. I think this stands for gRPC stands for gRPC Remote Procedure Control. It's a recursive acronym. Client and server library. The easiest way to expose and consume an API over the network. Tower. So this is inside of Hyper and Tonic. Modular components for building reliable clients and servers. Includes retry, load balancing, filtering, request limiting facilities, and more. Minimal portable API on top of operating systems. Invented I/O API. Let's see what these things do. Metal I/O. It's a fast low-level I/O library for Rust, focusing on non-blocking APIs, even event notification, building high performance input output outs with as little overhead as possible over the OS abstraction. Yeah, it's sweet. I don't know what any of it means, but it's sweet. Features and non-goals. I like non-goals. Tracing. It's off to the side here for some reason. Unified insight into application and libraries. Provides structured event-based data collection and logging. Okay. Bytes. Oh, that's an error, I guess. Maybe it's just because of the tiling window, but if you scroll all the way down, it doesn't get to the bytes portion. At the core, networking applications manipulate byte streams. Bytes provide a rich set of utilities for manipulating byte arrays. Makes sense. It's just version 1. It's funny. Cool. So we did that. Let's look at the GitHub. Fast. Zero cost abstraction gives you bare metal performance. Love it. Runtime for writing reliable asynchronous system applications with Rust programming language. Reliable. Leverages ownerships, type system concerns, modeling, scalable, minimal footprint. Okay, I'm sure we'll get enough to read in the book or in the tutorial. This tutorial will take you step by step through the process of building a Redis client server and we'll start with the basics of asynchronous programming with Rust and build up from there. We'll implement a subset of Redis commands, but we'll get a comprehensive tour of Tokyo. Should probably make a new project for this. Yeah, I can just put the Rust stuff in here. The project that you will build in this tutorial is available as Mini-Redis on GitHub. Mini-Redis is designed with the primary goal of learning Tokyo and is therefore very well commented. This means that Mini-Redis is missing some features that you want in your real Redis library. You can find production-ready Redis libraries on crates.io. We will use Mini-Redis directly in the tutorial. This allows us to use parts of Mini-Redis in the tutorial before we implement them later on. Okay, so they're gonna they build it already, and then they're gonna, yeah, so they build it all the way through, and there's probably some iterations, and now they're saying like, how do we make a tutorial? And then they just fill in the gaps so they can explain stuff later. Because that's a big problem with books is like, especially if you go through the Rust book, it's like, here we're going to teach you these things, but we have to use these other features to teach you this feature, but don't worry about this feature yet. We'll explain it later. And it does that a lot. And here they can just say, like, ignore this. At any point, if you get stuck, you can always get help on Discord or GitHub discussions. Don't worry about asking beginner questions. We'll start somewhere and have good help. Cool. Prereqs. If you're starting to be familiar with Rust, the Rust book is an excellent source to get started with. While not required, some experience with writing network code using the Rust standard library and other language can be helpful. No pre-exhausting knowledge of Redis is required, which is nice because our list had Redis question mark. So this is cool. We can learn Tokyo and Redis at the same time. How about it? Rust. We're getting started. Make sure you have Rust toolchain installed and ready to go. If you don't have it, easiest way is to install it using Rust Hub. The tutorial requires a minimum Rust version of 1.45, but the most recent stable version of Rust is recommended. Cool. You don't have to revert or anything. To check, run this. We did. We are at 1.53, which is higher than 1.46. You can see output like yada yada. Mini-Redis server. You can install the Mini-Redis server. This will be used to test our client as we build it. Cool. So let's do that. It's just installing from Crate.io, I guess. Make sure it was installed successfully by starting the server. Oh man, they're teasing us with the with starting it. It's like, here's what it's going to look like when you're done. Now, back to the grind. Then, in a separate terminal window, try to get the key foo using Mini-Redis CLI. See now. Okay. So we're going to start up the server, I guess. I don't actually know what's going on. Is that working? I didn't say what the output would be. Is the output? I'm going to predict that the output is going to be in this top terminal. It's good to make predictions so that you learn more as you go along. Like if you're wrong, you learn a lot. Predictions. Okay, I was wrong. Which makes sense, I guess, because this is running independently. So, but this is working. It's just running independently of what's going in this, which I guess might be the whole point since it's async stuff. I don't know. Let's find out. Ready to go. All right, that worked seamlessly, which is ideal. Love it. That's it. Everything's ready to go. Go to the next page. First, probably have to turn this off. starting fresh. Let's start fresh. Hello, Tokyo. Like it. We'll get started by writing a very basic Tokyo application. We'll connect to it. This is also one of those things where, just like saying it now, like I've seen this mentioned, and it just looks like one of those things that's so beyond what I can do. There would be like witchcraft if I knew how to do it. But I'm gonna learn how to do it, and then looking back, it won't be so bad. So that's cool. Those are cool things. We'll connect to the mini Redis server. Set the value of the key hello to world. It will connect to the Redis server. Set the value of the key hello to world. Okay. We'll then read back the key. This will be done using the mini Redis client. It's like a cache in our, it's like an async cache type thing. Is that what we're building or working with? Generate a new crate. Start by REST app. Yep. Redis. CD. Redis. Got our kernel, our cargo, and our source. And dependencies. And the following right below dependencies: Tokyo, Perl. What help do you need? I'm trying to copy a website, basically. We actually didn't delete it, so that's good. I'm trying to copy this website. Because what I basically want to do is this. I want to copy the website, and then we're going to build a dashboard in R that goes to an HTML file. And then we're going to embed that dashboard in their website so that when we go to present to them, we can be like, this is what, try it on, looks like this. This is you wearing our product. And then we're going to find data sources online that are more stable than what they're pulling in because they don't really have a process, I'm pretty sure. And then we're going to feed that data to the dashboard, and then we're going to do all the math and visuals and modeling and stuff. Hopefully we have time to do. Still not sure exactly which part of these should be done in Rust, but I'm planning on the web scraping being done in Rust, I guess. Yeah, step one was the web part, where I just don't know how to copy the website and get it like running locally or in my own domain or something like that, where I can play around with it. Oh no, I didn't start the timer. Okay, let me. You're going to do it in HTML5 and .NET. I don't know. I don't even know if it was me, really. I would have to try to match whatever they're doing, I guess. Probably HTML5. Like here. Flex dashboard. So this is the R stuff. This is what he wants to build the dashboard in. But we need to avoid using Shiny, is what I gathered, because we need the dashboard to run just on a regular HTTP server. Yeah. So if you go here, you should be able to access it from here, right? Like their style sheet should be posted somewhere. Right? Not necessarily. Link to the HTML.php. What is PHP? Like, it's like a dynamic, like linked, like it's pointing at a local file somewhere on their server. Let me see. My titles change. I hope so. That changed. This one has changed. Yeah, the HTML is referencing docs on their server. Or wherever they put it. Like you looked at the site. So you're saying I can't get it? Here. That's the calendar page, but that's the website. Anyways, let me know what you find. That would be super helpful. That's stage 1. All right, so we were putting Tokyo in our dependencies. Version. Okay, so they're just locking in the version to make sure that the tutorial works, I guess. It's kind of annoying because, I mean, I guess it's a necessity. What's cool about Vivaldi as a CSS debugger? Don't most browsers have a CSS debugger? I don't know what I'm talking about, but I feel like they would. I mean, if it helps, then go Vivaldi. Never seen this. You've never seen a CSS debugger in a browser? Maybe it's new. That'd be cool. Huh. I'll have to check it out. Actually, let's. Let's see. Yeah, it's super basic. That's what I'm saying. It's like this place, any resources they have, they redirect towards like logistics. You don't need the style sheet, it's just containers and buttons. Describe the colors and font. Oh yeah. Well, that sounds like a good news. One day. Well, if 233 pages. Yeah, I mean, I would only need like a couple pages. You're saying just like rebuild it ourselves? Okay. Um, I was doing it. I was trying to copy it so that I could like cleanly integrate it if after the project they asked us to like come in and do it for real, like get it working on their actual website. Yeah, that's awesome. It's great news. But that's funny. Yeah, maybe they didn't have someone come in and do this for them. They just figured it out. Um, oh, that's only one. That's good news. That means we can keep working on future stages. Okay, where were we? Still adding dependencies. Oh, what am I doing? Yeah, I need to add mini Redis, which we just installed. Reschools is a good site. Don't, you know, don't knock it. Okay, fixed our cargo. My cargo, let's see. I wouldn't be surprised if the CS student made this website for free. Yeah, that's what I'm saying. It's like they have one person do it for them as a volunteer. That's the other part I was thinking is that if we get this working and they ever need someone to maintain it, we can try to put it on GitHub and then they can just get people from like UCF or Valencia or Seminole or whatever, like CS students to volunteer and help maintain it. You know, you could totally see that happening. But if it's like that's part of the reason I think this is doable, is that if it's written in Rust, like people will like using it, they'll like maintaining it because they get to learn Rust and they get to use Rust, and they won't have to do a ton because it's written in Rust. So like stuff that's compiled is working. But yeah, it'll be fast. I want to make it so they have like everything else is like from W3 school, and then just this one part of their site is just blaring fast Rust. That'd be hilarious. You want to use Rocket? I don't know. I was thinking about it. A lot of the things I was seeing were saying to use not Rocket, but use it's called like ActiXL or something. Like Rust has so if you ever want to look up something in Rust, it's great. You just say, "Are we something yet?" And then so like, "Are we web yet?" And they somehow just own all the .org domain names of this. So yeah, yes, and we're freaking fast. So yeah, ActEX. It was between this and Rocket from what I was seeing. But I mean, the Rocket website looks better, but this I think is more mature from what I was seeing. All the professionals I saw were using this instead of Rocket. And it has a gear icon, so how can you? Like Rocket looked more straightforward in terms of syntax when I on first impression, but that doesn't really mean anything. because I don't know what I'm doing. Neither do I. That's why it's great. We just have a link. Whoa. Oh yeah, this is what the guy was citing, was that um was this that ActIX had like one of the fastest benchmarks of the Rust languages. I don't know what all of this means, but yeah. I don't know if Rocket's even on here. I do love speed, even if it's way more than you need. I don't know what this is. Anyways, back to this. The fact that we mapped our arrow keys to the buffer changes. Like, I think, yeah, and I can list it. That's sweet. I do love speed. What's wrong with speed? Gotta go fast. Okay, write the code. Deal. Open the main RS. Open. Okay. Place the contents in the file with. So, whoa. What the heck? What is going on? Okay. Use any credits. So we're gonna import clients and results. Apparently we're gonna build these things later, but right now we're just gonna use them. Or are we just gonna start with like something functioning and then tear it apart? That'd be cool. Just like slowly replace something that's perfect with the source code. It's interesting. Okay, and then in main, we want to hash and Tokyo main. We're gonna add that feature to it. Okay, and then we have to, we're gonna make, oof. We're gonna make it public main. That's interesting. Like other things are gonna call main, have access to it. Async. So asynchronous, a public asynchronous main function. That returns a result. Oh, is that not autocomplete? I should probably. Alright, I'm trying to figure this out. Only match. Did that work? I don't think so. I'll have to figure out how to. I must not have added the autocomplete. I added the autocomplete offerings. Interesting. So we can add that to our We can add that to our to-do real quick. Let's go down here. Here, 5. Okay, and then this needs to be like, yeah. Crap. Auto. Okay. So we've got a result with a none type tuple. Okay. Open a client to many Redis address. Okay. So we're letting making a mutable variable client, setting a client, which we imported from many Redis, connect. And then this is our local this is our local port, our local IP, whatever it is. Local URI. 639. It's like a specification on top of it. And then we have to add a wait. And I guess that says that's like wait until everything has been synchronized, I guess. Okay. Let's leave some space here. So we're gonna just wait. I wish the we're gonna do this a lot, I guess. So let's just I don't know if this will work. No, this probably won't work. Let's just set like cover. I guess it has to. We want to go to here, projects, this, this. No right since last change. What? I guess it's in the wrong buffer. Okay, I do this. It's not. How do you add buffers? Let's find out. Open a new buffer with file. I think you might be still under. Okay. If it does not close your current buffer, just replaces it in the current window. You type buffers, your previous buffer should still be listed. Still open with linked memory. So that should work. It's just saying like it should be closed. If I go here, it's saying that it won't open. Yeah, alright, since your last. Is that because it doesn't say what buffer we're reading? Previous buffers should be listed. The only way to make them go away is with these things. Should switch back to using this. New. Edit. That's weird. I guess if I do this, it should work. Yeah. Okay, I guess that worked. I don't know why it was saying that it needed to be overridden. You know, Kata, glad you're here. Even if it was just you in the chat, happy to do it. It's always nice hanging out. It's super cool that I can switch between all my buffers. Like these extra arrows I have now on the keyboard. Anyways, yeah, so this is going to give us a quick way. For something I was thinking about earlier, we need a quick way to add to our big restart to-do list for our config. And there's a lot of rough stuff that I didn't add in, so I believe that the autocomplete isn't working. Like, that makes sense. What else was not working? I forgot. I forget all that. What? No change successfully around. I can't change the buffer unless I write it. It's interesting. Oh, I didn't change this one. That makes sense. Well, what did you learn? Okay. Use any Redis. Interesting that we're using the result type from mini Redis. And then, okay, we need to add Tokyo main trade. We're streaming till 11, by the way. I don't care what the timer says. I did the timer wrong, so another hour. Okay, and then let's go to deleting it. Oh, well, actually, we need to do this. We need to make this public, apparently, and async, which I think you have to do a lot. And then it needs to result of a blank people. Okay. We need room for comments, so let mutable client equal to client. And it's going to be 127.0.0.1 6379 rates. Leave room for comment. Extra room. And we're going to client set hello sigma key world into, and then await. We just have to have a wait to get of everything. Good work. So let results. It. Hello. Not. Wait. So. To open a connection to the mini Redis address, and then set hello key for opening the address, and then setting the hello key. Yeah, so it's a key. So we're setting. Ooh, what's that? Right. No. Okay. I don't know why that was so hard. Getting key. Set hello with the value world into it. Okay, so it's just a key value pair. Into just means like into the list, or into the data. So I'm not exactly sure what we're doing. Right. Formatting. Okay. Then it returns an OK wrapped around with an empty tuple, which is the type that we wanted to return. So OK is a part of results. At least it should be. Results is part of mini Redis, which I haven't looked at, so but it should. Okay. Man, water is good. Make sure the mini Redis server is running in a separate terminal. We'll run a mini Redis server. I already did that right. Okay. Should go to switch. We can run. So this is where we're going to run the cargo, but first we want to do the other stuff. So let's just go here real quick because this is going to be temporary. So we can run mini Redis. Why is that button no longer working? Oh, because I'm going to resize mode. Dang it. Keep doing that. Oh, that changes the bezel. Whoops. There we go. Keep doing that. Mini Redis server. I guess that's working. It doesn't like do feedback, I guess. in case we haven't installed it, but I think we have. I feel like I'm about to sneeze. Excuse me. Man, that oh, hit it in turn. Accidentally. That quick mute button hotkey was pro advice. It's happened twice now. It's already installed. That's what I thought. Now should be able to now run my Redis application. I should save this first, right? Yeah. And the full source code here. Here we should be able to target it with that. Oh, you have to cd to alright. Further on. I know this is overlapping the chat a little bit, but it should mostly happen on the left. These things take a little bit. Alright, breaking it down, I like it. Let's take some time to go over what we just did. There isn't much code, but a lot has happened. That sounds right. Okay, cool. So we got a result here. It's just in front of the camera. I like it. So we got value from the server. So print this. Result equals some binary. This means binary by convention world. So it's a binary string of world. That's cool. Yeah, so we set result equal to, we just did we just had a call in it manually called hello. Said, given the hello key, what is hello key? What is the value stored at the hello key? And it was just built into the binary. Cool. Now, let's go over what we just did. So, let mute client connect. Oh wait. The client connect function is provided by the mini Redis crate. It asynchronously establishes a transfer connection protocol connection, TCP connection, with the specified remote address. Once the connection is established, a client handle is returned. Okay. Even though the operation is performed asynchronously, the code we write looks synchronous. The only indication that the operation is asynchronous is the .await operator. What is asynchronous program? Most computer programs execute in the same order that it is written. The first line executes, then the next, and so on. With synchronous programming, when a program encounters an operation that cannot be completed immediately, it will block until the operation completes. This is how I do everything. For example, establishing a TCP connection requires an exchange with a peer over the network, which can take a sizable amount of time. During this time, a thread is blocked. With asynchronous programming, operations that cannot complete immediately are suspended to the background. The thread is not blocked and can continue running other things. Once the operation completes, the task is unsuspended and continues processing from where it left off. Okay. Operation cannot complete immediately and suspended to the background. The thread is not blocked. Nice. Continue running other things. The operation completes, the task is unsuspended and continues processing where it left off. Nice. Our example from before only has one task, so nothing happens while it is suspended, but asynchronous programs typically have many such tasks. So I can run something here and be like, oh, this is going to take a while. Let me just keep doing this. Why don't you just do this all the time? Just do as much as possible. For example, from like as long as you can ensure that it keeps like it'll stop. Like if each piece doesn't need the other pieces, it'll just go until the maximum threads are utilized, and then it just waits, and then this thing finishes, and then it goes to the next one. It's like when you go to the self checkout line at Costco. You have one line, but you have many servers, so which is more efficient. That's like what this is doing. That's pretty sweet. But it's not confined by. I mean, it is confined by the physical world. It's a lot easier to have threads on a computer than it is to build a checkout station. But asynchronous programs typically have many such tasks. Although asynchronous programming can result in faster application, it often results in much more complicated programs. Programmers are required to track all the state necessary to resume work once the asynchronous operation completes. Historically, this is used in Airbrush. And that's why Rust is awesome, because you don't have to worry about that. Compile time, green threading. Rust implements asynchronous programming using a feature called async await. Functions that perform asynchronous operations are labeled with the async keyword. For example, the connect function is defined like this. Mini Redis result, mini Redis client, Tokyo net, TO socket address, connect T socket, and it gets wrong. TO socket address, T was result client. So it takes a socket address. Interesting. The async function definition looks like a regular synchronous function, but operates asynchronously. Result, Rust transforms the async function at compile time into a routine that operates asynchronously. Any calls to .await within the async function yield control back to the thread. It's like await results. The thread may do other work while the operation processes in the background. This is so chill. Although other languages implement async await too, Rust takes a unique approach. Primarily, Rust async operations are lazy executions. This results in different runtime semantics than other languages. It doesn't quite make sense yet, don't worry. We will explore async await more throughout the guide. Sweet. Using async await, async functions are called like any other Rust function. However, calling these functions does not result in the function body executing. Instead, async functions are called like any other Rust function. However, calling these functions does not result in the function body executing. Instead, calling an async function returns a value representing the operation. It's conceptually analogous to a zero-hour deploy. To actually run the operation, you should use the .await operator on the return value. So it's saying this portion is just a function. It's just like a function with a preloaded value waiting to be executed. The .await lets you execute it. For example, given program, say world, and world. When say world does not execute the body, say world. So you're just setting this variable equal to a function. And then you're printing hello, and then you're printing world. The return value of an async function is an anonymous type that implements the feature trait. Return value of a async function is an anonymous type that implements the feature trait. A async main function. The main function used to launch the application differs from the usual one found in most REST crates. It is an async function. It is annotated. Okay, so the difference between this and things found in most REST crates is that it's an async and that it's annotated with Tokio main. Sort of like inheritance. An async function is used as we want to enter an asynchronous context. However, asynchronous functions must be executed by a runtime. The runtime contains the asynchronous task scheduler, provides evented input outputs, timers, etc. The runtime does not automatically start, so the main function needs to start it. Man, whoever decided to make this must have just like had a moment where they saw Rust and were like, whoa, you know what we could do with this? Tokio. That person's a genius, and not me. Okay. So we're here. Should keep a track of where we're at. No, it doesn't do this thing anymore. Interesting. Okay. The Tokio main function is a macro. Okay. It transforms the async function main into a synchronous function main. Interesting. We're just undoing what we were doing. That initializes a runtime instance and executes the async main function. So the function is asynchronous, but this is our synchronous runtime. The following gets transformed into, okay, so this is the bare bones. The details of the Tokio runtime will be covered later. So function main, let mutable RT, which is runtime, equal Tokio runtime, new, unwrap. RT, block on, async, print line, and yeah, so async the contents. So that's cool. It's just like a big shortcut for the runtime. That makes sense. It's like asynchronous, but you need to have a runtime directed for it. When depending on Tokio for this tutorial, the full feature flag is enabled. Tokio has a lot of functionality: TCP, UDP, Unix, sockets, timers, sync utilities, multiple scheduler types, etc. Not all applications need all functionality. When attempting to optimize compile time or the end application footprint, the application can decide to opt into only the features it uses. Now use the full feature when depending on Tokio, which we can switch to super easily like that. Man, okay, but it's already there, so it doesn't matter. Whoops, I can't mess it up though. Yeah. Okay. Let's not get too crazy. What did I do this for? I don't know. Just gotta make sure you save stuff or else it'll go away. Alright, let's keep going. We got a half hour. See what we can do in half an hour. This is going to be so sweet when we get it working with our project here. We're going to use this to hopefully web crawl and scrape some data. I know it can be done easily in something else, but something else is in Rust. So are we going? Okay, spawning. We're going to shift gears, start working on the Redis server. First, move the client set get code from the previous section to an example file. See, this is like good practice. I need like some iterations of just like general, how do you manage files in a project? You know, I'm not a software anything. Never really built apps before, you know. Just import scikit-learn, that's all I know how to do. We can run this. Okay, this way we can run it against our server. Okay, from the previous section to an example file, so you can run it in our server. Okay. So we would like to not close this. We can do that stuff down here. This is like a decent setup because you guys can see if I run a one-line command, you can see it here. And then the output should go down here, and then the rest should be over here. It's the idea, anyway. I can just keep clearing this. So here, and I should do it. Okay, so we're making an examples file. I don't know what P does, but okay. Make directory dash P examples. Move source main to examples load Redis. So we had a main, and now we're putting that in examples folder. Yeah. If we, I wonder if we, yeah, so our source is empty now, so we're gonna have to remake our main folder. But if we, let's go back. Return examples. And so we just renamed our main file as we were moving it to examples. Okay. Accepting sockets. The first thing our Redis server needs to do is to accept inbound TCP sockets. This is done with the Tokyo Net TCP listener. First thing our Redis server needs to do is accept inbound TCP sockets done with Tokyo TCP listener. Many of Tokyo's types are named the same as their synchronous equivalent in the Rust standard library. When it makes sense, Tokyo exposes the same APIs as standard, but using the async function. Okay, so they tried to duplicate. Oh, not that. A TCP listener is bound to port 6379. Then sockets are accepted in a loop. Each socket is processed, then closed. Wonder why it's port 6379. For now, we will read the command, print it to standard out, and respond with an error. What file do they want us to write this in? I guess a new one. This. Oops. Whoops. Okay. We want to go to source and then make a main. Okay, cool. Okay, and now we should be able to. We're gonna have to close this, I guess. Can I just close the one buffer? Close. Yes. Let's see. Close. A buffer. Very close to Stack Overflow. And Stack Overflow is just wonderful. So Stack Overflow testing. Word of caution, W in buffer W does not stand for write, but wipeout. Interesting. Upload buffer. What are you doing now? So really didn't get the buffer. Unload buffer, current buffer, and delete it from the buffer list. The buffer was changed. This fails. Unless when okay, in which case I'll change your loss. Okay, so I should really just map meter Q to this so that anytime I quit, it doesn't matter if I have buffers open or not. I would want it to check if buffers are open though before I quit everything. Let me make sure it works the way I think it works. It should just close the current buffer. Yeah, perfect. Let's actually see if what's his name has. Oh, I closed all that, didn't I? We can do it from here since we already have. I guess we don't have our engine set up. It's okay, let's look. We want to look for colon BD, see how he's mapping his buffer delete. Let's speed this up. A bit more efficiencies in our config. Continuous improvement, baby. Just never stop improving. I can post this code. I'm like, still had to write a server just open forever. Good. Alright, full screen. Looking for colon ED. Doesn't have it mapped at all. Interesting. Interesting. I feel like that's right on the edge of my capabilities of editing the Vim config. I'd have to do some conditional, I think, to make it map to the queue. I'd have to check if multiple buffers are open first. Because there's two states, right? It's an enumeration term Rust speak, where you either have multiple buffers open or you don't. Anyways, what that means is that I can now, since we moved the file around, it would have messed stuff up. Now we can edit Actually, I wonder if he has a key for that. I don't know if he would. On edit projects code name. Oh no, this is way higher, right? This is big. Then. Okay. Beautiful. Let's see. Let's see if this thing is here. 1E. Okay. So we said no remap, leader E, so leader edit to carriage return equals expand I don't know exactly what this means. Percent ph dot this carriage return. Open new file adjacent to current file. Let's try it. So we're gonna have to close that anyway. This is under his. This is nice, like this. Anyways, it's under his keyboard shortcuts. Keyboard shortcuts, nice. It was. Ah. Insert. What's happening? Why are we in vision mode? Okay. Open file. JSON. So normal mode, no remap. So we don't want to like chain our maps together. Here, E. So we're mapping what used to be. So we're mapping leader E to colon E. So leader E now calls colon E. And then the rest of this stuff, I don't know what it is. This. And carriage return. Okay, well, we're gonna have to. What is this called? You have something that you should understand before you remove it. Chester fence. Fence. Shouldn't. I gotta better type these. Yeah, so this is the idea. So you shouldn't remove it until you know it's there. Know why it's there. Yeah, that's exactly what we're thinking. This is gonna be like the most creepy or cryptic. Let's see. This stuff. I don't know what this stuff does. It's like what I'm thinking. Anyways, should be able to wrap this, and then we're gonna execute this anyway. And we should be able to meter E. For normal mode. Oh, I have to exit this as well. That's interesting. Guess we have to close all of it. But from here on, it will work. Okay, so this is an empty buffer. Okay, so I should be able to buy the cargo. And then I should be able to do this. Oh, does that get like the last thing in my thing? What did I need? I needed that, and then I needed Tokyo, and then I needed my Tokyo or my Redis, and then I wanted force and main. And that's an empty file. That's what we were expecting. And then this is cool. We're running stuff. And then we want to. I don't think we need our nvim anymore. But we did want the list of things to add to the nvim. Okay, so that's going to be not this, all the way back to this, and then config to do. Now we can do this again. It's sweet, and they're all local. It's all tiled. It's all right there. That's sick. Oh, it's sick. Love it. Anyways, back to where we were. Don't need that. We've gone all the way down the rabbit hole, all the way back out. We got, what, 25 minutes till the end of the stream. See what we can do. We should tweet at Tokyo, because Tokyo is sick. Versus better. One day I'm gonna get clever enough to think of my own config stuff. But using other people's has been really efficient. Okay. Use Tokyo net TCP. Let's TCP stream. So this is Pascal case. I'm pretty sure is what it's called. It's not camel case, but it's good to like encapsulate ideas, like with the Chester things thing. As long as you know what they mean, there should be a word for that to encapsulate that idea. Encapsulate the idea of encapsulating ideas. Okay. TCP listener, TCP stream. Anyways, connection and frame. Okay, so we're adding more stuff that we're going to build later. Cool. I assume we're going to build it later. Like, got connection and frame. So framing is here. That might be where we do it. We're now using raw Tokyo, so that's cool. We're like fully bootstrapping. It's they did the beginning parts. Okay, Tokyo main async function main. It's not public this time. Fine. Yes. Okay. Listener. Listener. And then 7, 1, 6, 3, 7, 9. Dot awaits for all the functions. So TCP listener bind the listener to the address. So we're on that address listening with our TCP listener. And it's awaiting, which means that it's being called through the Tokyo main runtime. And we're unwrapping it. Let's see what this is. Might not have the question mark yet. So we're unwrapping it so that it gets the value out of it. It's going to be wrapped in the result, and we just want the value in the result, not the. We don't want a result type. We want whatever the result type is holding. And I wish I could horizontally scroll. Get a new mouse for Prime Day 2. Just maximum efficiency. Okay. Second item. Something. Let's socket. Link type. We have a message from the studio. What's the message? Schnoodle mail. She wants nuggies? We just got nuggies. We gotta get the sauce. They shorted us on the sauce. We can't get nuggies 2 days in a row. Starting to notice a habit for me. Listener accept. Second item contains the IP. Okay. Import of the new mystery. Wait dot. Does this get better if I like make it bigger? Sometimes these go away. Yeah. Okay. See if that's okay. No, it doesn't. It doesn't help. Still, says who? I don't know. The chickens. Okay. The second item, so we're in a loop. This is an interesting thing about Rust, is that you can just say loop and it just does an infinite loop. You just better have a closed condition in it. It's quick, it's fast, it's run forever. That's called bad web dev. That's called bad web dev. The stream? You probably only apply the auto scaling to the page. Oh, I see what you're saying, but not the nav container. All the websites are like that. It's super annoying. I hate scrolling. Should make more stuff with streamers in mind. It's a great way to share code. Oh yeah. Whoops. Okay. The new connection. What's in mind? Yeah, that too. Well, for streaming, I have to like blow the font really high. Like if I wasn't streaming, I would be like probably like this, where I can read as much as possible. But this is terrible for a phone. Gotta read more books. That's too small. This is about 120. Okay, so the second item contains the IP and port of the new connection. I mean, you can see they're in the boundary, so that's good. But not for this, right? Oh, yes, collapse the menu. Yeah, exactly. You would just do this on their phone, I guess. I don't know. The second item contains the IP and port of the new connection. Okay. So we're saying, yeah, so it's basically saying that we're not going to use the second item because we're just assigning two variables. So this returns two things when we unwrap it. Which is the IP and the port. Okay, so this is the port of this IP. It basically contains this, which we don't need, so we're just underscoring it and setting it an anonymous variable. But the socket, so it returns the socket and the IP port. We do want the socket. So listener, accept, await, unwrap. So whenever we get an accept in our loop, we're going to process the socket. We're going to process the socket. And await is a asynchronous function. Apparently. I don't know from where. But because we didn't import it, but maybe from Tokyo main. I don't know. I don't think that would work. I also like how it auto places your curls. It's nice. So the next, so we have our main, and then okay, process. Duh, it's right there. I was like, where's process come from? At least I knew he was at a place. Okay. I really should probably word things first. I don't know. I don't know what's the best way to do that in. Okay, so we're making asynchronous. It is asynchronous. Duh, it's a wait. And then function process socket. The TCP stream. And then the code. The connection. Let's read right is frames instead of byte streams. Interesting. Frames. Right. Instead. Right. Mouse equals A. Come on. Dang it. Mini Redis. Mini Redis. Whoa. Whoa. Connection type. Connection lets us read write as frames instead of byte streams. Connection type is defined by mini Redis. Use connection. Connection. New. Connection will let us read write Redis frames instead of byte streams. What are frames? Right. Capital sum. Frame. Equals. Next. Wait. So if it equals that, this is like a weird thing that you can do in Rust. You can say if and assignment. You can put variable assignments in if statements. So we're saying we're basically saying if some frame is equal to connection reframe await unwrap, which is weird because I would think you wouldn't unwrap that since it's getting the value out of a result. But maybe that's just checking the type. Unwrap. So if that is true, if that logic is true, then, oh, because it's the variable, yeah. Then we set some frame equal to it. So, is that right? I think so. If some frame. So we set frame equal to the output. Oh, I see. Yeah, I think so. Yeah. I think that makes sense. That's the wrong thing. Line. We got 1 minute. We're gonna finish this code block and run it. Get that sweet, sweet dopamine. Frame. Line dot frame. Respond within here. Response. I always spell response wrong. Okay. String. Response equal frame error unimplemented to string. And connection right frame to x dot weight dot unwrap. I guess I don't fully understand the if let sum, or even the if let, I guess. Okay, close, close. So that's what it's doing, the same process. It takes the socket of the string. So it takes the string. So it takes a socket of type TCP stream, and then connection lets us read frames instead of bytes. By the default is to read bytes. And then type, okay, and that's defined in mini Redis. I don't have access to yet. It's here. We imported it. Or we haven't built it yet. And now if let sum frame equals, so we're taking that connection from the socket, and we're saying read frame dot await unwrap. So if the frame okay, so it's basically, so if let sum, so sum is basically saying that if connection, if read frame returns something, set frame equal to the output of the unwrap. And we're going to print the frame and respond with error. So let response will frame error unimplemented to string, connection right frame, reference response, await unwrap. Is this isn't the else part, right? Okay, so it's just continuously moving through this. That should be, that makes sense. What is the type? Is it none type? Rust. Error. It's okay or error. Right. Big flag. So yeah, it's if you don't want to use match. What is a match? It's we need to specify a failure, use an else. Right, matched I. If let some, if let construct reads if let destructures number into some I to evaluate the block. So it has to be a type. No. It's if it equals a number. So this is some 7. So this unwrap must return something, some frame. I don't know that frame is a type. It just sets it to whatever it returns. But if it returns nothing, it doesn't do anything. Okay. Returns an error. Okay. Now run this. Except okay. Let's write this. Now, go. Should print unimplemented. Try to run. Then we can run the hello Redis example Oh, this has started the server? Ah, started a listener on that port. And now it's reading it. It's going to read it. Once we tell it to. So let's see. Um, okay, stats running on the right. Look at the chat. And we need to go back to here. That's just a matrix. Let's filing this. Unlimited. Okay. In the server terminal, the output is, oh yeah, it is. Got array, bulk, binary set, bulk, binary hello, bulk, binary word, world. Because we didn't return a frame. Connection lets us read frames. But in the hello Reddit, hello was a binary. Sort of makes sense. Okay, we're gonna stop at concurrency. Can we bookmark this? So no, I guess not. We'll stop at concurrency. And go from there. That's good though. This is fun. We did a lot of stuff. Nothing extraordinarily successful, but a good bit of progress. We're gonna about 10 minutes over. That's fine. I'm gonna go get some nuggies, I guess. All right, we should be good to close. Was it? Should be able to just do that. Okay. And let's just finish reviewing and turn everything else off. The plan. Sounds like we're going to make some inroads on this off screen. Not by mirroring their website, but just by recreating it since it's so simple apparently. And then this we didn't really look at too much, but well. Then look at this. We've got a different guy looking data sources, but I'll probably do some simple ones on my own. Some obvious ones, maybe not simple. And then this is why we're looking at Tokyo, so that we can scrape the data and feed it to the website somehow. I guess Reddit will cache it for us. We might not even need a database. That would be sick if we didn't need a database. And we're going to take with map and videos. That's hopefully that's the easy part. So like that. And then make a copy. This we already talked about. So I need to ask the organizers about openness and maybe get a domain name. And this HTML, we looked at some HTML. We're learning by working. Didn't look at WebAssembly. We're looking at Tokyo and we're getting some Redis experience too. Thanks to them just giving us an example of that. JavaScript or Postgres. It would be great if we didn't need Postgres. And what else were we for? Yeah, so here, this we talked about, this wasn't working, so I was gonna run this off screen, but I'm gonna use a different solution. Which is nice, because this was gonna be huge, I think, because it's set up so strangely to where everything's a link, and it's just incredible amount of stuff. Like a lot of websites, I think, point somewhere else. Anyways, this is fun. We didn't hit our follower goal, but that gives me another week to, maybe Saturday to recover from this first week, and then if we do hit the follower goal next week, it won't apply until that Saturday, so that's good. It's a win-win. Right. I will see you guys later. Have a good one.